Hi and welcome. My name is Rafael Taubinger and I have here the Raspberry Pi Pico. So this video, it's about getting started with the Raspberry Pi Pico and IAR Embedded Workbench for ARM. The Raspberry Pi is populated with the RP2040 microcontroller that was designed by Raspberry Pi in UK. The RP2040 features a dual-core ARM Cortex-M0 Plus processor with 264K internal RAM and support for up to 60 MB of off-chip flash. A wide range of flexible I/O options includes I2C, SPI, and programmable I/Os. This makes it possible for beginners and also experts to develop endless possible applications for this small and affordable $4 microcontroller board. There is plenty of documentation, examples at GitHub, the SDK, and videos available explaining the features and providing detailed information on how to use the board. I will focus in demonstrating the step-by-step on how to run an example out of the box on this popular board from IAR Embedded Workbench for ARM, and focus on the necessary IDE configurations like MCU selection, Lincoln file, and more. The IAR Embedded Workbench for ARM can be downloaded from iar.com/EWARM, and there is an evaluation edition and also the 32K Kickstart code size limited edition in case you don't have a commercial license. One of the biggest advantages aside of the optimized code generation is the use of advanced debug capabilities available in the IAR Systems toolbox. The board provides a 3-pin Arm Serial Wire Debug, the SWD port, and by connecting the debugger wiring connections, you can make full advantage of JTAG probes supported by the IDE, but of course also the iJet from IAR, and I will use it in the demonstration. You can also see it in the picture. You can of course also debug external build executables from the Raspberry Pi Pico SDK, so generated with other compilers. You only need to make sure that the debug information is enabled and the compatible ELF-DWAR file is generated with the right flags like displayed in the screen. The pin connection to be used when you have either an ARM20 connector or a MIPI 1020 connector. That's mainly a standard for ARM microcontrollers and processors. It's illustrated in the table that you can see now. So if you need more information, you can always go to developer.arm.com. So I will quickly show you how to run the example out of the box, build and debug a session, and initially I will show you how to import an external ELF file generated via, for example, CMake in the Raspberry Pi Pico SDK. Great, so let's move into practice. So I have here now IAR Embedded Workbench for ARM open. As I mentioned before, you can download either the code size limit version or the evaluation version in case you don't have a license. The first screen that will appear, it's always the IAR Information Center, and there is actually an example delivered with the IDE. So if you go to the examples, you should be able to see Raspberry Pi, and if we just open the Pico Blinky example here, we can just copy it here to a known folder, and you will see that it's out of the box example with some source code already. So it mainly has the main function and also some additional functions related to the GPIO. And it's always the most important is of course to make sure the settings are correct if you, for example, start a new project. And we start here by looking on the device. You can select a device, but also the core, the Cortex-M0 Plus here. The advantage of selecting the device is that the IDE will know exactly what kind of code should be generated from the compiler side, but also when you start a debug session, it will know what device is expected on the other side, aside of course, the memory mapping and so on. So selecting the device will automatically select a linker file that you can still configure or adjust depending on your needs. And finally, we need to make sure we select the right driver here for the JTAG probe. So we have here iJet as a debugging probe. It's the probe from IAR. And that's mainly what we need to do. And from here, we mainly need to build this project. So I will just select build all. That should be done quickly. And if the wiring and everything is correct, we should be able to download here to the target. So the flashing will happen. And once this process is completed, we will of course stop at main, where you have full control of the debugging session. So as you can see, we can look inside memory, we can look the registers and so on. So the memory window, it's already open here under view memory, and if there is a known symbol, you can of course navigate through it like main, that's always known. If you want to have a look on the registers, that's of course also available. So you can just select specific peripherals or registers you want to look into. You could even blink the LED from here. So you are looking inside the device and you have full control. You can just step by step here run it from main. You can also go here to assembly code. If you double click, you can even set a breakpoint either on C level or on the assembly level. So if I set a breakpoint here and that application run, every time we hit that line of code, it will of course stop. But there is way more you can do. If I just click here, you will see that there are different kind of breakpoints that are available. There are code breakpoints that could be transformed in a conditional breakpoint. Only if a condition is true, it will stop the code. There might also be log breakpoints, but aside of that, you can of course also use data breakpoints. So if a specific memory address is accessed, it will also stop. So very handy, very powerful. You can build and debug your application directly on the Raspberry Pi Pico board. But what I also want to show you quickly here is that if you have an external built application, for example, if you are using the Raspberry Pi Pico SDK, you know, there is a lot of examples, a lot of source code. I can mainly open here what I downloaded from GitHub. I mean, you have lots of good examples that you can use as reference. But if you use it the way it's recommended, with building it via scripting, CMake, and so on, you will get at the end the final output, not generated with IAR, but with other compilers. And what we can do here, for example, if we look on what has been built, I can just look inside here the Blinky, and there is an ELF file. From this ELF.dwarf file, what we need to do, we actually need to create an empty project. Easily be done here under project, create new, and there is even an option for external build executable. And I can just proceed here. It will ask for a name. I can just name it debug. And from here we get some hints on what needs to be done. It's really straightforward. I need to start by adding that ELF.dwarf file. So if we go under Pico build debug, then we have the Blinky one, so we can select the blink elf file. That's the first step. And additionally, we also need to make sure that we are selecting the right device. So if I go to general options, I can scroll down here to Raspberry Pi, the right device. As we saw before, the linker file that will not really play a big role here will be used. But we need to make sure that we select the right driver here, iJet, that I'm using. And finally, probably just to make sure that everything works smoothly, we should just force the vector table base to be set to 0 here. This is of course optional, so you can avoid some warnings, but that should not be a problem at all. So once this is completed, we can just confirm here, and I should be now good to connect to the target. First do the download and debug of this external build application. So it was generated from the Raspberry Pi Pico SDK with CMake and GCC. And the great step here is actually that you can point to the source code. So if we go to the source code here under the Pico examples, I can select here the blinky C, and since the debug symbols are available, the debugger will be able to get in sync. So as you can see, this is the source code, and we land at main here. If I step in here, if there is any other file required, it will also be able to localize that. So from the initial path to the first file, so you can find all the other files when it's possible. So again, you have full control with this external build executable, and that might be worth. Of course, if you look here, there are many examples available. So if you just want to try it out, that's a great start here. Good. So, to summarize it, the IAR Embedded Workbench for ARM makes it easy for beginners and experts to write an application and keep full control when debugging the application. Even externally built executables can be fully debugged. So what are you waiting for? Just try it out now. Thank you for your time, and I hope you enjoyed this video.